And we are live. Good morning, everyone. Welcome to you all to this third edition of Battery Startup Lunch with a great lineup today as well. Very happy to have all of the different speakers and companies being represented here today. As you can see on the screen with different startups today from mea-tec, Batri, b.again, EPTTAS, and Floatech. With very different technologies and battery-related work being done from these different companies. Very excited to hear from all of them. Just a few elements on the practical information. Please keep your microphone off while someone else is presenting. This meeting is recorded, and there will be a publicly available recording made later after this event. So if you want to catch up on the different slides that were presented today, you may see them on the recording later. Please don't hesitate to use the chat and Q&A to ask some questions to the speakers. They will try to answer them after the presentation or to answer them in writing if time forbids. So without further ado, I will leave the floor to our first speaker, who will be today Dr. Stephen Hu, who is CTO for Batri. Stephen, please, the floor is yours, and you can start sharing.
So good afternoon and good morning, everyone. So thanks very much, Beppe, for the opportunity to speak here. My name's Steve Hughes. I'm the CTO at Batri. There we go, it's working, hope. So who are Batri? We are a South Wales Bridgend-based company, I have to say beautiful sunny South Wales, and we develop battery materials for the emerging, or focusing on the emerging sodium battery opportunity here. So we are driving advancements through the technologies that we use. We're scaling our materials from conceptual lab size up to commercially industrial scale processes, so hundreds of kilos of batches, this kind of thing. And our work has been supported quite extensively through UK government funding, so Innovate UK, the Faraday Institution, and UKRI, as well as the APC have all backed the work that we're doing, which gives us good credence and backing. We work closely with a number of other universities, such as Swansea University, so all of our materials are tested, validated, and verified. And we're undertaking some significant projects now with some Korean partners, which is the SNAP program. And like I say, the APC funding that we've recently won is to scale our material to potentially ton per day scale. So that's really important for us. Our material, our main material, or focus of our first material is an anode material, a hard carbon for sodium-ion batteries, and we use coal, locally sourced coal, to create this. So we've got a really secure and scalable supply chain. The good thing about talking to battery people is I don't have to go into supply chain issues and too much into what the current market is. But if we just look at sodium-ion batteries and the potential for growth in this market, it's accelerating rapidly. So we're seeing in forecasts an increased production growing at this sort of exponential rate, 150% increase in the tracked production volume for 2030 over the last couple of years. And this is also seen with headlines that are coming out, such as Cattle's Nextra battery. We've had the US putting solid sodium batteries on the grid and things like that. So there's a lot of significant backing coming here. The key thing that we're always asked is, where are sodium batteries used? And so I just wanted to touch on this a little bit. It's not just for static storage opportunities. It's not just for grid scale storage, although that will take up a lot of the beachhead market. We're also looking at non-road automotive applications. So your 2-3-wheelers, scooters, e-rickshaws, this kind of thing, and your non-road applications, so forklift trucks or the vehicles that you'd have at airports. They make up some really interesting markets that are niche, but they're high value niche. So this is where sodium has some key advantages. What are the challenges at the moment? So supply chain for the materials is the obvious one, and this is why we're doing what we're doing. Currently, it says 92% here, but I've seen a recent statistic that's more like 97% of anode production comes out of China. We're looking obviously to secure supply chain here in Europe, so we're developing that for the anode material, but we also have cathode material in development. And this helps long term through reduced emissions of supply and this kind of thing. So we can make greener batteries. The UK government noticed this a few years ago. They were maybe a little late on the bandwagon, saying that we could become, UK and Europe could be the leading global hub for sodium batteries. But since they made that announcement, China's picked up the baton. So we've really got to push hard on this and find partners to develop it. Just touching on what makes our anode material a little bit different. Like I say, we use locally sourced material, so coal from a mine that is 15 kilometers down the road from where we're based. We convert this into the hard carbon. So most people think of coal and they think of polluting power stations, but the pollution from power stations is the emission of CO2. That CO2 is the carbon that we want to keep. So by using coal, we've got a really high carbon content material, so really good resource efficiency, lower energy in terms of production of the ultimate hard carbon from the coal when you compare it to a biowaste, and fewer greenhouse gas emissions as well, because it's such a pure starting material to start with. Just a couple of slides on the data of our materials, so I'll skip through these quite quickly, but we're commercially viable. We match and outperform a lot of the materials that are available on the market. And again, this data is all backed up through academic verification. Some impressive first cycle data here, so reaching about 330 milliamp hours per gram. We've got really good long-term stability here, so you can see after 50 cycles it's totally flat, and then we did an extended accelerated lifetime over 10,000 cycles where we retained above approximately 90% of its capacity. The really interesting thing with the material that we've produced as well is this rate performance. So in real world applications where we're seeing these batteries go into potentially automotive, but power tools or static storage, where you do need to cope with peaks and troughs, the performance of our anode material is really impressive. Looking at what we're looking for here and how we want to interact with people, we're already working quite extensively with academia in the UK, so you can see some of the names there that we're working with, but we're really trying to expand now into Europe, trying to get our material out there into the people who are really developing cells, and making sure that we can help support this as that need grows and so on. So really open for potential partnerships on horizon applications or putting it into cell development programs with people. And then breaking news really, earlier this week we incorporated Batri US, so we can start working on the market over there. As everyone's aware, with all of the tariff things that are going on at the moment, it's really important to have US based manufacturing if you want to go and work in the US. So we're able to work on these transatlantic partnerships as well now, and that's really opening a really interesting market for us. We are a startup, so forgive me for putting, or a scale up, I should say. So forgive me for putting this this slide up. We are obviously, as everyone always is, in an investment round, and we're currently seeking strategic partners who want to join us on this journey. We've got some clear goals for the next 12 months in terms of scaling this material to that 100 kilo batches and ton per day scale process. The SNAP program that I touched on at the very beginning develops and integrates cells into products that will be made by our Korean partners. So there's a full cell development pathway that we're looking at. And then we're seeking partners who want to actually put these into demonstration and pilot programs as well, whether that's e-mobility or storage applications. Obviously, like I say, we're very open for collaboration here. We're not one of these companies that comes to you and says, this is what we've got, you take it as it is. We like to work with people and try and give them what they need. I've rushed through this because I want to have a bit of time for questions if there were any, but thank you very much for listening.
Thank you so much. Good presentation, clear plan, and great work your company is seeking to do. If there are any questions, please don't hesitate to write them. We've got about 2 minutes before I move on to the next speaker. And otherwise, also, Stephen, I see you've got you put an email here. Don't hesitate to put it in the chat afterwards as well, so people can keep on seeing it if they want to contact you. I see there is a question from Ravi. Why is it focused on sodium? Why are you focused on sodium?
Okay, yes. So I didn't touch on this at all. So the current battery market is obviously totally dominated by lithium technologies. And if we look at the global supply chain here, around 90% of it is controlled in some way by China or comes out of it. So there are really strong geopolitical reasons for looking to create European supply chains and move away from the dominance of lithium. Lithium has obviously these geo-restricted materials, so lithium's only found in certain locations. Cobalt, nickel, all of these things are only mined in certain places, whereas the materials that go into a sodium-ion battery are found globally and unrestricted almost. They're everywhere, very ubiquitous. So we believe that this offers a really good solution for large grid storage, and like I put in there, some of those off-road mobility applications where you can make your batteries and your materials in country. You're not dependent on imports from other countries. So yeah, that's why we focused on sodium. We believe that this is a good way to enable countries to have a little bit more energy security, and it takes away some of the dominance and market manipulation that's possible through the current technologies.
Great, thank you. There was another question on the cost in the Q&A, but I'm afraid I have to move on to the next speaker. Don't hesitate, Stephen, to go in there and answer in writing directly on the chat while others are presenting, so they get the information. Thank you so much, Stephen. Thank you for taking the time today. I will now present the next speaker who is from the company mea-tec, and this is Emre Aslaki. Sorry if I mispronounced your family name here. Emre, if you are here.
So, I present?
Yes, if you can share
Okay.
your presentation, we see you.
Here you go.
Okay, the floor is yours, Emre.
Hi, everyone. Thank you, first of all, to BEPA for giving this opportunity to pitch our projects and company and who we are. Actually, we are founded in 2022, and we have with the two founder, myself, Emre, and also the COO is the Erencan. We are located in 3 countries, and Turkey, UK, and Germany. And we are also pretty international team, which we have employees around the world. And our also key competences are AI-related solutions, battery solutions. This can be embedded, this can be cloud or any other. And this is our journey, and we have started in 2022, Q1. And our first customer was one of the biggest battery manufacturer, Farsis Energy. And then based on this first customer, we also very quickly accelerated our growth to getting other projects from 2 other big tier 1 suppliers, both in Germany and also in Austria. In parallel, we have started also our innovation projects and also the collaboration with the universities. And so far, we have applied 5 different public funding projects as a coordinator, and 5 of them are granted. And also, we established the partnership with the different universities around Europe, including Imperial College, Fraunhofer, Southern Denmark University, and such. Also, we are pretty active in the Horizon calls. What we have as a solution, we have 3 main solutions here. What we have is the first is the BMS for the physical system, which is already commercialized. And we have the second one is the battery in the cloud, which we are working on it. It will be ready for the POC very soon. And the third one is the battery passport. And if you break it down into each product, and we have the BMS system, which has hardware and then the software, the advanced software, which we are working, especially nowadays, we are also intensively working for the AI-driven functions to fit into the real hardware. This is a little bit, how I say, challenge for each and every provider to fit these advanced algorithms into the physical system, but we now do this application. We also have the POC ready applications there, and our solutions also applicable for both application EV and BESS. What is different in our product? Mentioned this is AI driven, and we have the hardware independent solution, which means if you have your own hardware, we can come with our advanced software and then fit your architecture and then run with our software. This is of course safety compliant, and as we all know, there are many BMS suppliers, but there are many. Unfortunately, there are very less automotive grade BMS suppliers. We are one of them. And also the key functions, SOC, SMH, and the safety functions, we are implementing with the advanced techniques using physics-informed machine learning techniques there to have the best accuracy. And of course, the model-based development is important for the modularity of the software component. This is how our second product, battery analytics. Actually, we have two different platforms. One applicable for the EV, for the fleet management. The another one is for battery energy storages. And here we use what we have in the physical BMS. Physical BMS can only detect what happens, but in the battery analytics software, we have smart algorithms in the cloud which can predict future. That makes the difference. And here we implement all of those things in the cloud application. And another thing is in the physical system, everything is different. There we are using Simulink, Simscape, and real hardware. But when we move to the cloud, we use AI. We integrate our software into the AWS or other providers. I mean, things are very different, but at the end, the logic is somehow we implement those two logic with our battery competence in the background. Then this is how our solution looks like as a in the user interface. We have here performance criteria, safety, health, and warranty. And then we can see each and every node in our platform of the customer. And this is also one of the architectural review, how it works. We get the data from physical system, from BMS. Actually, we have already this data available. And then we got this data either over TCP/IP protocol directly with Wi-Fi or 5G, or we got this with this SCADA. This depends on the application, which application we are talking about. And the data come to our cloud, and accordingly, we run all of our advanced algorithms and then physical the modeling which we did for the battery and cell. Our third product is battery passport platform, which we offer to our customers. In Europe, there are 6 to 7 battery passport providers, but we are different than them. How? And what they do is they get the data from physical system, put it cloud, and then read it out. And we do differently. We create a digital twin of the battery, and we get the data. We use this data to also create the usable information for the operation. We call it battery passport integrated digital twin in the cloud. This makes us different than the other competitors. That means we also bring our battery know-how into an application to give the service to our customers. Actually, our product platform is already ready for the POCs. We have a couple of POCs which we are now running on the background with our partners. And other than that, what we are looking is actually we have, as mentioned, we have 3 products. One is already commercialized. The other 2 is we are barely ready for the POCs. What we are looking for the POC partners that we can validate our solution, and then we can also collaborate for the opportunities for our products. Thanks for listening us.
Thank you so much, Emre. Very clear. We have your email here, so that's perfect for those who want to see. Don't hesitate to put it in the chat afterwards so people still have access. If there are any questions for Emre, please don't hesitate. We have 2 minutes. And I myself, I was wondering, so you talked about those two other products. When do you expect they will be ready for commercialization or?
Next 6 months, we intensively will be working for the POCs, get in touch with the potential customers. We already got in touch, but we will get in touch more. And we want to see our interfaces, how we collaborate with the real application. And accordingly, I believe we will be ready for the Q1 for the commercialization.
Great. I see a question here. A few questions coming in. So for state of health predictions, so what kind of algorithms you are using?
I saw it for the
great.
EIS. Okay. Actually, the EIS is, we are aware of this technology. Actually, this is next generation for BMS systems. In one of our project now, we are using, it is R&D project, but we are using it for the prediction. Actually, SOH prediction with the EIS is kind of replacement of the AI predictions, which we aware. And we are also involved in a couple of projects to explore this innovation as well together with the other partners. Some other traditional, what we are using in our physical system, I always split the two. In our physical system, we use a Kalman filter for SOC and SOH. But when we go to the cloud, we use their physics information learning, which means we have physical model, the electrochemical or the ECM or SPM we have, and plus we have our machine learning. And we can also see there with the predictions, the hysteresis. And accordingly, these two models fit each other and do the prediction. One important thing is, until now, we were doing with the lab data, we were developing our physics-based model with the lab data. But what we are now trying to do is we try to do this with the real-time data. This is the innovation. That means we will not be asking to our customers give us the lab data or experimental data because it will cost them time and money. And what we do is we develop our core algorithms, core model, put in the cloud, and with the real-time data, we can update this model and then optimize it for the use. This is what we are doing in our solution. Another question is from Martin.
Yeah, I will. Sorry, I will let you answer this one by writing on the chat. Sorry, because I need to move on to the next presentation now for time's sake. Thank you so much, Emmer, for answering the question and for your presentation.
My pleasure. Thank you too.
Thank you. I will now move on to Maria Regufe, who is the head of valorization and R&D department for b.again. Maria, please, the floor is yours.
Okay, thank you. I will share my presentation. Okay, can you see?
Yes, it's loading still. Okay, I see it now. Perfect. You can go ahead.
Okay, perfect. Thank you. I would like to thank the opportunity to present the company b.again. Good morning, everyone. My name is Maria João Ruf, and I'm head of valorization and R&D department of b.again. I will do a brief presentation of b.again and our business areas we are currently on. b.again is a recent company within the DST group with just over 3 years. Our focus is essentially on two business areas. The first one, battery recycling of end-of-life lithium-ion batteries and production scrap. And the second one, development and implement battery energy storage systems. Our mission is based on the several topics: collection, reception, handling, storage, reconditioning, and recycling end-of-life lithium-ion batteries, processing and recycling of end-of-life leads and production scrap, ensuring the valorization of critical resources and metals through recycling and material recovery, providing technological solutions that enable the sustainable and responsible valorization and use lithium-ion batteries. And these points allow us to say the future is a cycle that we begin again today. We are part of a large Portuguese company located in Braga, the ST Group, which includes more than 3,000 employees spread across over 50 companies and present in more than 15 countries. Initially, the DST Group began with engineering and constructions, but quickly expanded into other areas such as environment, like b.again, renewable energies, telecommunications, real estate, among other areas. DST Group be a pioneer in several fields and always at the forefront of innovation and technology. We can see also in these graphs some indicators regarding the DST Group demonstrating significant growth over the years. Focus on b.again. b.again is another example of this innovation in DST Group. Having defined our business areas during these 3 years, we present to our clients a range of processes and services that cover a significant part of battery value chain. Focusing mainly on battery reconditioning and reuse, the logistics parts, safe handling and recycling of end-of-life batteries, and in the next stage, metal recovery after the production of the main recycling product, which is the black mass. We are currently operating in the logistics part of the end-of-life lithium-ion batteries and developing our battery energy storage systems projects. Our mechanical recycling line is under licensing and will start operating at the beginning of next year, 2026. In parallel, we are developing our quality control processes for our products, as well as hydrometallurgical processes for metal recovery and valorization of these materials. We have a battery warehouse allowing us to safely store our end-of-life batteries that we are collecting now. We are also prepared to carry out ADR certified transport and have the necessary environmental license for the transport and reception these end-of-life batteries. Regarding the mechanical process, as I mentioned before, we are currently working on the implementation of the recycling line, which will allow us to recover materials from production scrap, for example, such as battery cathodes and anode materials. And during the process, we will also recover ferrous and non-ferrous components and others, while the black mass produced will undergo strict quality control, ensuring a quality product for our client. In very general terms, a brief presentation of our mechanical process. Batteries are first diagnosed to assess either they can be used in a second life applications, for example, for best solutions, or either they should go into the recycling line. In the case of recycling, they are discharged to ensure safe handling, and after dismantled, they follow through a shredding process and electrolyte drying, which allows for the mechanical separation of certain components such as aluminium, copper, plastics, and others. The remaining fraction becomes black mass, and this is then subjected to chemical processes for metal extraction and do the purification, enable the recovery of metals of interest. For example, either there's a mixed composition of nickel, cobalt, and manganese for the NMC batteries, or as battery-grade materials ready to be used in the new production of new cathodes for batteries. Regarding the battery energy storage systems, we are prepared to design customized solutions based on the client's consumption needs. Our services and applications cover the residential, commercial, industrial, and utility sectors, and depending on the requirements, we deliver different solutions and functionalities, aiming to develop and implement efficient systems that can provide services such as voltage and frequency regulation or peak shaving solutions, demand response, between others. This is our brief presentation regarding the b.again, and I'm conclude my presentation. I think in that time. Thank you for the attention, and I'm happy to reply some questions or feed questions. Thank you.
Thank you so much, Maria. Great work here done. I see there's your email, the email of the company on the bottom left here for those interested. There was one question from Iman asking if you're working on LFP recycling.
Yeah. We are working on the whole type of chemistries. I referred NMC, but also LFP. In the case of LFP, end-of-life batteries and production scrap for of LFP batteries, cathodes in this case.
Thank you. So maybe for one last questions, but I don't see any. If some questions pop up in the next minutes, please, of course, Maria, feel free to answer in writing like has been done earlier. There's another question that popped up, but I will need to move on to the next speaker, unfortunately. So, Maria, thank you so much.
Thank you.
Please go in the chat and answer any more questions that they have for you. And so, moving on then to the next speaker, I would like to welcome Robert Jacobson to the floor.
Hi.
Also, Maria, if you can stop sharing on your side, so that's perfect. So Robert Jacobson is the founder and CEO of EPTTAS. I'm not sure if to say EPTTAS or EPTTAS, but I'll let you correct for me, Robert. No worries. The floor is yours, and thank you for coming here today.
Thank you very much. And EPTTAS is perfectly fine to say, so that is okay. Let me see here. Can you see the screen?
Yes, but not in presentation mode yet.
Let me see here. It's a little bit slow when I try to put it in presentation mode.
No worries. Let's take the time needed.
Okay, here we go. So it's fine?
Not yet.
Not yet?
But let's give it a few seconds. Okay, now good. If it keeps on being a bit slow, I can take over for you. I'll let you know.
Yeah. Okay, so thank you very much, as I mentioned, for BEPA to host these sessions. It's really, really good to see all of the other presentations as well. So yeah, EPTTAS, my name is Robert Jacobson, as was mentioned. I'm the founder and CEO, and we have a big focus on preventing battery fires. So I will go through that today. Let me see here. It was a little bit quick. Yeah, so short about myself, we have a mock-up, I would say. Can you see it?
I'm sorry, Robert, I think because it's changing, but it's very slow. Do you think maybe I should share because it makes also your video a bit slower. Maybe because of your computer. Let me try and share maybe on my side, if you don't mind.
Should I stop sharing?
Wait, sorry, Andreas saying fine. Can you quickly, very sorry, but can you quickly try to move on to the next slide and see if it's fast?
Yeah, this is the slide. It's saying speaking today and the team. Can you see that one?
Yeah. Okay.
It's okay.
Sorry, let's keep going like this. Sorry.
Okay.
Maybe
Hopefully
it's just
it will work then.
Yeah.
So I'm not going to go too much into this, but we are three founders, and we have a long background from the mobility, IoT, and electrification of cars, trucks, and vehicles. So you can see some text here. I'm not going to read all of it, but it's back from GPS data was state of the art in 2006, and nobody believed that you could see moving objects on a screen. And the whole journey with data from vehicles, and then you have UR, which was working close with Tesla and the whole electrification of vehicles, and Alexi, which is the CTO. And then we founded EPTTAS in late 23, and we kicking off now in 25. So next slide, can you see it? Okay, then it probably
working fine now. Sorry for joining before we.
No problem. That's fine. So today I'm just going to focus on two challenges that we work on. It's battery fires and the need of data. So the question we get all the time, which is quite usual, is, are battery fires a problem? And we work with this every day. I've been working with this topic for many years, but here are some examples. On the top left corner, it's a Belgium incident, 24 buses burnt up at the depot. And what is happening when these incidents the buses are burning, it's not only the buses, it's the whole depot. So if you see the text here, it was 700 rooftop solar panels also destroyed, and the whole infrastructure. And then you have also on the right, you have the e-bikes, kick scooters, etc., which probably most people have seen for now. It's happening quite often, and for example in London it's now forbidden to take the kick scooters to the underground. Everything is related to the same. And on the left down you can see an example from the following consequences of one battery fire. So here is a ferry company that has now banned electric vehicles from being transported on the ships. So it's all again due to the concern that if one catches fire you have a potential disaster. And next slide, there's some recent numbers coming from the UK, which is more fact-based. So basically it states that fires caused by lithium-ion batteries has doubled in 2 years. And I think the numbers are quite amazing. So UK fire brigades are now tackling at least 3 lithium-ion battery fires a day. So it is unfortunately a growing problem. And this is, of course, also exponential to the growth of EV and kick scooters, etc. So we can clearly see the numbers are increasing at the same speed as the impact of vehicles, etc. The next question, so I think the answer from our side, we are quite subjective, but I think the fact is stating the same. The answer is yes, it's a problem. And the next question we get is, why don't anyone solve the problem? And there's 3 things I will bring up today. One, it's quite, there are some, of course, it's a big topic of safety in batteries, but almost all of them are picking up when it's happening. So that means fires are usually detected only after the chemical process has started, which is called thermal runaway, that probably most of you are aware of, has begun. Then you have a scenario with a fragmented responsibility. So you have battery makers, the OEMs producing vehicles, trucks, etc., leasing companies, importers, sellers. And in a global market, everyone wants to sell. It's small margins. So I think we can state that risks are unfortunately downplayed. So if you ask any of these stakeholders, most of them will say that the risk is 0. but the numbers are showing different. The last big factor that is really driving this, of course, is the political pressure. So governments are pushing for rapid electrification for reaching the climate goals. You have the Green Deal in Europe for heavy-duty electric vehicles, etc. And it's a little bit tableau to say here, but it could be possible that we don't speak too much about the safety issues, which is coming along. So technical barriers, industry silence, and political pressure makes this a little bit of a cocktail of stakeholders and impacts that is causing the problem. So our solution to the problem. So we looked into this again from our background from electrification from the start. We saw it coming. We have seen the lack of solutions, and we dived into it from an angle of seeing, is it possible to prevent it from happening? Not only isolating incidents, but actually preventing it. So what we have done is a software solution that is able to pick up the early thermal runaway up to 60 minutes before, which is a game changer. So we take it through the whole value chain, and we alert the stakeholders that I mentioned, if it's fleet operators, vehicle owners, battery manufacturers, on board or remote, or via APIs or whatever is needed. And hence we can prevent it from happening. The next thing I wanted to just briefly talk about, it is part of the same topic, is the data need. So I saw a few of the slides today. The need of BMS data and other data from the units, vehicles, trucks, etc., is a must. To operate these kind of vehicles and trucks and units, you must have data. So we, at the bottom of what we do, we have a high-performance open-end infrastructure to deal with real-time vehicle data, and basically we consume everything. So if it's standardized parameters, if it's private protocols, if it's any type of data, we are able to consume it, and we deal with it. We interpret it, we validate it, and we make it available to make the batteries safer. The market, I think someone was in it before. It's a huge market. It's growing. It's we target the high capacity battery globally. Go-to-market strategy. We, as mentioned, we target all high capacity, high energy batteries. We target all the verticals. That means electric vehicles, buses, heavy transport, and so on. We use channels, so either direct sales or partners, insurance companies, OEMs, and as we speak, we are putting up a lot of pilots around the world. So to sum up, battery fires are a rising risk. Early detection beats reacting while it happens. Confirmed gap in the market, and we are now expanding, globally. So I'm not sure of the time, but that was it. Thank you.
Thank you so much, Robert. No, we're very good on the time. Very perfect. Maybe 1 or 2 minutes for any questions if there are in the chat. I don't see any at the moment, but let's see. So thank you so much. Sorry again for the beginning. I think it was my computer being slow, actually.
That's fine. And I'll just post my email here if anyone wants to reach out afterwards.
Perfect. That is perfect. So let's see, because I don't see any at the moment. I think it was also very clear, and indeed I had never thought of that cocktail with the political pressure as well, and trying to go fast. So that's also an interesting aspect. Very well. Well, of course, if there are questions coming, which might happen, please don't hesitate to answer in the chat. I will now go to Juan for the next presentation and the last one of the day, and we are quite on time. So Juan, we have Dr. Juan Jose Villatella today, who is the CTO and co-founder for Floatech. Thanks a lot also, Juan, for coming in today and presenting. Please go ahead.
Thank you, and thanks everyone for connecting. I've already included my email in the chat because I imagine some people may be rushing to get lunch after my talk, so you have my email. And I am CTO and co-founder of Floatech. We are a startup based in Madrid that supplies components for the next generation battery. So we supply to cell producers. And as you probably know, there is a significant number of different battery chemistries now being under development and under scale up. So this is just one example of what the future may look like. And I think there is consensus that in the next decade, particularly, there'll be a much stronger fraction of silicon anodes and lithium metal anodes that will, to some extent, displace graphite, initially coexisting and later probably displace graphite. And this is because they have much higher capacity to store lithium. So for instance, roughly 1 kilogram of silicon could replace 10 kilograms of graphite. From the point of view of sourcing and scarcity, it makes a lot of sense, and there are many other reasons. This is an example of a forecast from a well-known intelligence company, Benchmark, who predicted a while ago that this was going to grow exponentially, and that is happening. My personal view is that it's just a couple of years behind their forecast, but it's not a matter of if silicon and lithium metal will be used, but a matter of when. What Floatech does is it supplies 3 products for this next generation of battery cells. One is a silicon anode for liquid electrolyte batteries. So that's in Europe called generation 3B. We launched the second one, which is again a silicon anode for solid electrolyte cells, and that's called 4A. And more recently this year, we started supplying a very thin silicon interlayer, which is used for lithium metal to improve its performance. So I'll give you more details of these 3. But in general, as a company, what we do is we work with the cell producer, and by giving them these products, we accelerate their cell development at the early stage with the long-term view of supplying to them these materials at scale. Importantly, these are finished products. They are anodes or sheets that can therefore be integrated in existing machinery for cell manufacture. Now that's important because for the cell producer and ultimately for the user of the battery, this reduces cost by removing a lot of the capex and opex in cell production. So we don't produce powders that need solvents, binders, slurries, drying, and so on. So we eliminate about 5 stages in electrode processing by providing a free finished anode. Our projection is that these products will have a cost of about 10 euros per kilowatt, below 10 euros per kilowatt hour, which is well within the range for batteries to meet the cost targets, for instance, for electric vehicles. Our clients are electronics and automotive OEMs who are in the early stages of cell development in North America, Europe, and South Korea and Japan predominantly. They are either in the electronics or automotive business or new cell producers, particularly in Europe. And they can be either companies focused on silicon specific batteries or lithium metal, or who are looking for fast charge designs. And occasionally we are also approached by producers of other cell components like electrolytes or associated machinery and so on. And if there's anyone, of course, listening to this presentation, and if you're interested in the product, feel free to drop me an email and we can discuss further. Just briefly on the manufacturing process and how this enables eliminating slurries, we essentially chemically transform a precursor, which is a silicon gas, into a silicon paper. This is a chemical process that works in flow. So it's a continuous process. So what we put in is a gas, what we get out is a silicon paper. And that's what enables eliminating binders, powders, and so on. And then if that is pressed onto a current collector, it becomes an anode, or it can be supplied as a freestanding material, and that's integrated in the cell. The material has 100% silicon, therefore the full capacity of is exploited in the battery. So this is what gives us access to high performance battery cells. And I won't go into the details, but from a chemical engineering point of view, the nature of the process makes it about 10 times more cost effective and scalable than what our competitors are using, which is based on thin film technologies from optoelectronics. This is what it looks like in the early days in our demo unit. So you can see this is silicon being produced on a conveyor belt, and you can see this is coming out, and this is essentially like paper in terms of handling, and therefore compatible with roll-to-roll processing. The process is protected by patents in the most important territories around the world, and we have a freedom to operate report. For liquid electrolytes, if you wanted to integrate it, what you can expect, we can supply materials with a wide range of aerial capacities and up to 10 milliamp hours square centimeter. So essentially more than a regular cathode could match. If this is of interest to you, if you look inside, this is essentially a porous network, and this is important because that way it contains the expansion of the anode active material within the pores. Capacity of the anode, about 3,100 milliamp hour per gram, and cyclability in the hundreds of ranges. And any cell producer would want to know more details, which I'm happy to share offline. This is the second product. This is the anode applied used for solid-state batteries, and the example I show here is for a ceramic-based electrolyte, a sulfide-based, which is, as you may know, the predominant choice for many electronic companies in Asia and the automotive companies. And what we see already after a year is capacity retention in the hundreds of cycles, no cell expansion, and we are working with a couple of leading companies and research centers in developing new manufacturing schemes based on the ability to make freestanding material. If you are a lithium metal battery company, our product is a very thin layer. This goes between the metal foil and the electrolyte. And what it does is it lowers the over potential for plating and stripping and increases cell cyclability through this lithophilic interlayer. We can make them very thin, typically 8 microns, but we have a target of going down to 2 microns in thickness, and this is already being tested by established battery producers in Europe and elsewhere. To finish with where we are and where we will be, we were born out of a European Research Council program in a research center in Madrid, and got a couple of a seal of excellence and award and a seal of strategic excellence from the European Innovation Council. And after a seed round, we were able to build our own facilities and have a demo reactor whose purpose is to supply materials for cell development and validation, with a team of 8 employees growing to 10 later this year. And what we will be doing in the next years is now that the product is validated, to scale up for production for initial markets. Our facilities here in Madrid are located in a great place, surrounded by all these 4 gigafactories that are being built as we speak. And we have enough floor space to fit a production unit for smaller markets such as electronics and so on. So a nominal capacity of about up to 1.5 gigawatt hour, and looking already at what the following stage would be. And with that, I thank you for your attention, and I'm happy to take questions.
Thank you so much, Juan. Great presentation, great prospects here. I see there was one question asking how high you can go in mass loading without binder, and also if a high mass loading electrode is really stable without binder.
Any thickness is stable without binder, and in fact, the higher the thickness or the mass loading, the more stable it is.
Okay, great. So straight to the point. I don't know if there are any more questions that will come in. I don't see for the moment. we're reaching towards the end of today's battery startup lunch edition. So just before everyone leaves and until there are more questions, I would just like to tell you all that the next edition of the battery startup lunch will be on October 21st with a new lineup which is still being built. So stay tuned to learn more about the next edition and who will be presenting there. And also next week we'll have another BEPA webinar on the 18th of September from 10 to 11. Please reach on our socials to check it out. It will be on the batteries passport specifically. And my colleague Ariana has put the different informations in the chat for you to check directly. I don't see any more questions for Juan, which have come up. So with this, I thank all the speakers, of course, for your participation and for the great presentations and the great work that you're doing with the battery space in Europe. Very excited to see what happens next for you. And thank you everyone who attended as well. We hope to see you soon in the other BEPA events, whether online or offline. And so thank you all. I will now close this webinar. Have all a great day.
Thank you. Thank you.
Thank you. Bye.
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 Thank you, everyone.
The logos in the last slide.